Hello. In this video, we are going to discover some properties of the natural logarithm, ln. The intensity of this video is mild, and my name is Hussein Lamir Ramandi. Let's review some basic material. Assume B is some positive number, which is different from 1. It has to be different from 1, but I forgot to mention it here. Then log x with base b is equal to y if and only if b to the y is equal to x. This is saying that we say, so this is just basically the definition of log. B to the y is equal to x means that log of x with base b is equal to y. Recall that ln x is log x in base with base e. So the same fact about ln is going to hold. Ln x is equal to y. It means that e to the y is equal to x. In this video, I refer to these facts by star. I call them star. We're going to use it in multiple places, so let's keep in mind. Okay, what properties are we going to talk about today? The first property is that ln e to the x is equal to x, and e to the ln x is equal to x as well. If you already know that e to the x and ln x are inverse of each other, these two properties are trivial. We're also going to show that ln of xy is equal to ln x plus ln y, and ln of x over y is equal to ln x minus ln y. In other words, ln makes multiplication and addition, and it makes division a subtraction. Ln of x to the power r is equal to r times ln x. This holds for any real number r. And whenever b is some positive number, which is different from 1, ln of x to the b is equal to ln x over ln b. Okay, let's start proving these properties. Okay, first we start with ln e to the x is equal to x. Let's call ln e to the x t, and then by property star, e to the t is equal to the e to the x. Since e to the x was a one-to-one function, then t has to be x. But what was t? T was ln e to the x. So ln e to the x is equal to x. So this is the first property is proved. Now we show that e to the ln x is equal to x. Let's put t equal to ln x. Then again by star, e to the t is equal to x, but this already proves what we want to prove, because t is ln x, and we already have that e to the ln x is equal to x. So far it's pretty easy. Okay, now we are going to talk about the property about multiplication. Ln xy is equal to ln x plus ln y. Again, we start by putting t equals ln x and s equals ln y. Then again by star, we're going to have that e to the t is equal to x and e to the s is equal to y. Let's multiply these equations or the values in two sides of the equation, then we have that xy is equal to e to the t times e to the s, which is going to be e to the t plus s. This is using the fact that whenever you have uh, b to the alpha multiple times b to the beta, that's going to be b to the alpha plus beta. I'm using this fact. Also, let's take the ln from both sides of this identity. Then I'm going to get ln xy is equal to uh, ln e to the t plus s, but that's already t plus s. So that proves this property as well. Instead of going proving 4, I'll start with proving 5 first, because I'm going to use this property in order to prove 4, property 4. Okay, property 5 was ln x to the r is equal to r times ln x. Again, let t be ln x. Then by start, we're going to get e to the t is equal to x. Let's take the power to the r. Then we get e to the t to the r is equal to x to the r. But e to the t to the r is equal to e to the rt, and x to the r remains the same. Let's take the ln from both sides of this identity. Then what we get is that ln of xr is equal to ln of e to the rt. We use property 1 because by using property 1, we get that ln e to the rt is equal to rt. But we just had that t was ln x, so this value, this quantity, is equal to r times ln x. And this proves property 5. Now, by property 3 and property 5, we can easily prove property 4. Recall that property 4 was that ln x over y is equal to ln x minus ln y. Then we can write xy as x times y to the negative 1. So ln x over y is equal to ln x times y to the negative 1, which is equal to ln x plus ln y to the negative 1. But by property 5, we have that ln y to the negative 1 is going to be negative 1 times ln y, which means that this addition is going to be ln x minus ln y. That proves property 4. Okay, for property 6, we need to prove that ln x with base b is equal, log x with base b is equal to ln x over ln b. Okay, I'm writing down property star here in a different form, in a slightly different form. Log of a triangle with base b is equal to square means that b to the square is equal to the triangle. And we want to show that log of x with base b is equal to ln x over ln b. Let the square be ln x over ln b, and triangle be x. then it suffices. Then let Z be ln x over ln b. We will show that b to the z is equal to x. That gets the job done because of this property star here. Because if we show that b to the z is equal to x, what is z? Z is this square. So b to the square is going to be the triangle. So we're in good shape if we get this done. Okay, let's do it. Again, let t be ln x and s be ln b. Then e to the s is equal to b and e to the x is equal to t. Then we're going to let's compute b to the z. So we have everything. We just assigned some variables to all of the lns in this problem, and we can just compute b to the z now and see what happens. B to the z is equal to e to the s times z. But s was ln b and z was ln x over ln b. Ln b, these two ln b can cancel each other. So what we get is e to the ln x, but that's already x. So we established what we wanted. You see here, e to the x equals t was not used. T equals ln x was not used. This is I did not erase these values just because I wanted to show that in this kind of problems, if you assign variables to lns and try to compute some specific powers, you're going to reach the goal. I finished this video by one exercise. So the exercise is as follows. Assume A, B, C are positive real numbers such that B and C are different from 1. I want you to show that log A with base B is equal to times log B with base C is equal to log A with base C. Remember that all of the facts and techniques that we used in order to prove facts about log. We could use about log with base b. You can also use some facts in this video directly to prove this identity.